This is the first in a series of videos that I'm doing called Solidity by Example, where we walk through, build out, and execute different types of Solidity smart contracts. Now today we're going to be starting with a pretty basic example of a voting contract given to us by the Solidity documentation. In the future we're going to be looking at a couple of other contracts given to us by the Solidity documentation, but also building out a couple of our own, including an ERC20 token, an ERC721, as well as a couple of other financial transactional smart contracts. Now, to get started, let's go ahead and go into the Solidity documentation where we're going to see Solidity by example, and we have here a voting contract. Now, this is kind of a walkthrough of what's going on as far as the general overview, but what we want to do is actually dive deep into this code base. Now, if you go to the Remix Ethereum IDE, and you go to remix.ethereum.org, you'll also notice that we have this ballot.sol contract, which is almost an exact copy of the voting contract in the Solidity docs. So this is what we're going to be playing around with and building out. Now, when I first started looking at these smart contracts, I actually had trouble deploying them because I did not understand the different data types, but I also didn't understand the logic in them because I was new to Solidity. So I want to kind of walk through and deep dive exactly what's going on here so you have a better understanding of what is going on yourself and can maybe write out and build out your own logic in the future. So with that being said, let's go ahead and dive into some code. So in our Remix editor, we have our ballot contract. And this is the contract that when we deploy, it's going to basically implement a voting process. And it's also going to allow delegation, meaning that I, as a voter, can kind of give my vote away to someone else. So I'm going to go ahead and be deleting comments here and there to kind of make the code a little bit more cleaner. And what I often like to do when I'm looking at an existing code base is go to the constructor as far as the Solidity contract is concerned. The constructor is going to kind of give you a very good idea around what the initial state of the contract is going to be and give you kind of a good starting point, I think, for understanding what's going on. So in this constructor, it's taking in as an argument an array of proposal names. Now the array is of bytes of type bytes 32, meaning that we basically need to pass in an array of this type, and if this type of data is passed in, then the contract should deploy successfully. The first thing that we see in the constructor is we're setting a chairperson variable to the value of message.sender, meaning that I or whoever is deploying the contract is going to be the message sender, and we're setting this variable of chairperson that we've kind of defined here as a type of address, a visibility of public, meaning that I can view this variable both within the contract as well as from outside the contract. So let's say, for instance, from a client-side application or something like that. The next thing that we're doing is we have a mapping of voters, and a mapping is basically going to be kind of like a map or an object in JavaScript. And we're going to be defining that right here, where we're basically saying we have a voters variable, and the key of the voter is going to be the address, and the value is going to be voter. And that means we might want to go ahead and take a look at what a voter is. So if we go here, we see that we have a voter type or a voter struct, and the properties on here are going to be the weight. The weight is going to be how many votes this person basically has. So when we initialize, we're going to kind of give them an initial weight. And if another person basically gives their vote to this person, then the weight will kind of go up. The next thing that we have is a Boolean saying whether or not they voted. If they have voted, this will be true. And if they haven't, it will be false. The next thing that we have is an address of delegates. Now, this basically means that if I want to give my vote to someone else, then I will have a delegate address. If I have not given my vote to someone else, this delegate address will be basically a blank address. And then finally, we have the actual vote. So what is the thing that I'm voting for? What is the index of the thing that I'm voting for? And this is basically going to be the index of the array that we kind of are passing into that constructor. So we'll take a look at that more in a moment. So basically what we're basically doing in the constructor here is we're setting a voter with the address of the chairperson, the weight of that voter to be 1. And that's kind of all we're doing for that voter itself, I guess you could say. And then finally, we're going to map over all of the different proposal names in this array. And we're going to go ahead and create a new proposal for each one of them. So we have an array of proposals, and then we also have a proposal struct. So let's go ahead and take a look at that. This is the array. We're kind of initializing it as an empty array, but every item in this array should be a type of proposal. And then, again, we're kind of going to loop over all of the different proposal names and create a new proposal. And in the proposal, we're going to go ahead and give the proposal name as the name that is the array item. And then we're setting the vote count to 0. So if we go to the struct of proposal, we'll see that kind of matches what we're expecting here. We're basically saying the name is of bytes 32 and the vote count is an integer. So that kind of makes a lot of sense because bytes 32 is what the name is, and then the vote count is 0, which is an integer. So we basically deploy this smart contract. We kind of map over or loop through all of the different proposal names, and this is going to go ahead and kind of set us up with the initial state of the contract. So if we go to our deploy and run transactions section here, and I go ahead and save this, you'll see that we have like this green check mark here. And under deploy, we have a way to pass in this array of proposal names. Now, if you actually just try to type in an array of strings or something like that and deploy this, what we're going to see is that we get some type of error, or this doesn't deploy properly, because this contract is expecting an array of bytes 32. So how do we actually get the bytes 32? Well, you can kind of come up with your own way, or you can maybe manually do this, but it's pretty easy using something like the ethers library. So we're going to go ahead and create a helper function that we're going to kind of be able to run locally to make this work. And then later on, we're going to look at how to actually just pass in a string by rewriting some of the code in our smart contract, and maybe talk about the trade-offs between using strings and bytes. So here I am in kind of an empty directory that I have on my computer. And I'm going to go ahead and make a new directory called transform. And this is going to be really basic, code base here. All we're going to do is create a single function for transforming a string into bytes 32. So, and maybe we'll create a function that does the vice versa as well. So to do that, I'm going to need the ethers library. So the first thing I might do is actually let me run npm inits. And this will go ahead and create a package.json file for me. And now I can say npm install or yarn add ethers. And this is going to be the library that we're going to be using. And then I'm going to go ahead and create a file also called parse bytes.js. And then I might also have one called create bytes. So create bytes is going to allow us to pass in a string, and parse bytes is going to allow us to pass in bytes and kind of do that. So I'm going to go ahead and open this up in my text editor. And let's go ahead and do create bytes first. So the first thing we'll do here is we'll go ahead and require ethers. And next we'll go ahead and create a function. And then for the actual invocation of that function, we need to pass in the arguments from the command line. And what we're going to need to do now is kind of have these arguments coming in. And this way we can kind of say we want to execute this file, and then we want to pass in another argument, which will be something like the name of the person that we want to create the bytes for, or the string, I guess you could say. And we'll go ahead and get the name out of this array. And then we'll go ahead and create a variable called bytes, and we'll set this to ethers.utils.format bytes 32 string, passing in the name. And this basically, this function here, format bytes 32 string, allows you to pass in a string and it returns bytes. And then we can now say console.log bytes or bytes. And now we can just get a, bytes 32 value from any string. So what we should be able to do now is run this code from our terminal. So I'm going to go ahead and open up the command line, and I'm going to say node create bytes, and I'm going to pass in my name. And there we go. We have our data that we can use now. So I might go ahead and say node create bytes and have another candidate. So the two people that we're going to be voting on are going to be Nader and Ashley. And we have the bytes that we can use. And we can now try to deploy that contract again using this data. So I'm going to go ahead and copy that to my clipboard. And I'm going to go back here and I'm going to paste in that first value here. I'm going to copy this. I'm going to paste in the second value here. And we're going to go ahead and try to deploy this contract. And I think what we need to do now is actually wrap these in quotes. So I'm going to try this one more time. And wrapping these in some double quotes. And if we deploy now, we should see that the deployment is successful. And we have a little green check mark here, and we're ready to continue building. Now, if I go down to deployed contracts, I should now see that I can start interacting with our contracts. We haven't gone over a lot of these other functions yet, but we actually have the chairperson. We talked about that. So if you look at the address that I deployed from, it ends here with DC4. So if we go down to chairperson, you should see that it is DC4. So that's me, and that seems to be working properly. Now, the first thing we might want to look at is giving someone the right to vote. So for that, we'll check out the give right to vote function here. Go ahead and delete those comments. And in give right to vote, the argument here that we have is the address. So we basically, as an admin or as a chairperson, we want to pass in an address and let them vote. And we're going to see that we have a couple of checks. And the way that checks are done essentially in Solidity, at least in this example here, is we're using this require statement and we're passing in some type of check to happen. And for this require statement to be successful and for us to continue the execution of this function, this needs to be true. So we basically want to make sure that the message sender is the chairperson, which makes a lot of sense. We want to make sure that the person that's trying to give the right to vote is the actual admin or the chairperson. And if they are not, then we stop execution and we throw an error and we basically say only chairperson can give the right to vote. The next thing we want to make sure is that the voter has not already voted. And the way that we do that is we kind of get a reference to the voter by looking in the voter's mapping and getting the instance of that voter. And we basically want to check to make sure that the voter.voted boolean is false. When we initialize a new voter, the default value is going to be false. And that means they have not voted. If they have voted, this will be true and this will not pass. And we will basically say the voter has already voted. The next thing that we're going to do, and the final check that we're going to have, is to make sure that the voter has not already been given the right to vote. Because if they have, then the weight will not be 0, and this check will not pass. And then finally, we basically just set the weight for that voter to 1, and then now they are allowed to vote. And they will also be allowed to be delegated a vote. And that's what we're going to go ahead and look at next. And I think when I first kind of looked at this contract, this was the part that maybe confused me the most because I didn't really understand what was happening here. But if we actually maybe go back and read these comments, we're kind of going to see that we can delegate our vote to the voter to address to which we want the vote to be delegated to, which kind of was a little bit confusing to me. So let's kind of walk through and try to understand this a little better. Now, what I'm going to basically be able to do here is I'm going to be able to pass in the address that I want to give my vote to. So I can say, okay, I don't want to vote, but I want to give the right for my vote to someone else, and then they can vote, and my vote is going to kind of be counted for whoever they vote. So let's see how we're going to make this work. The first thing that we're going to do is we're going to go ahead and get a reference to the current voter that is sending this transaction. So if I'm the person sending the transaction, I'm going to get an instance of that voter by saying voters message.sender, using the mapping of voters and getting the reference to me. And it's going to first check to make sure that I haven't already voted. And if I have already voted, this is going to fail, and we're going to say you already voted. The next thing I want to do is make sure that I'm not delegating the vote for myself, because that would make a lot of sense. Instead, I need to be delegating to someone else. And then this is a very interesting loop that we're going to be going through right here. We're going to be looping, or it's kind of like a while loop, and in reality, it's not going to be an array that we're looping over. And instead, we're going to basically say the first thing that we want to make sure is that the delegate that we're basically trying to give the vote to does not have an empty address. Because if their address is empty, then we can just delegate the vote to them, and we can kind of skip past all of this code and continue on here. But if the address is not empty, that basically means they've already delegated their vote to someone else. So we need to now go ahead and reassign who we want our vote delegated to whom they've delegated their vote to. And then this basically is going to keep mapping, or I would say keep looping over, and kind of it's going to keep going until this is false, in the sense of the address actually is empty. And then if it is empty, that means that this person has not delegated their vote to anyone else. So this is kind of a tricky piece of code for me at first, because I didn't quite understand it. But basically the general idea is this. I want to delegate my vote to someone else. Now, if I've delegated my vote to someone and they've already delegated their vote to someone else, we need to update who our actual address is to that final person, who is kind of the last person who all of these votes are delegated to. So we're kind of updating who our vote is delegated to based on who that person has delegated their vote to. Okay? So this is going to kind of either keep the to address to the person that we're delegating to, or the person that they've delegated to, and we're going to continue on. We now are going to mark the person that has sent this message to set their voted Boolean to true. We're going to go ahead and set their delegate to, like who they've delegated their vote to. We're going to now go ahead and create a new variable called delegate. And we're going to say if this person has already voted, meaning that they've already kind of gone through and voted in the past, we want to go ahead and update the vote count for the person that they voted for to equal the weight of whoever is now, casting this vote, plus whatever the vote count was already. And if they haven't, we're just going to go ahead and add on to their weight for this voter. So if they've already voted, we go ahead and tack on the votes to the vote count. If they haven't voted, we go ahead and add on the weight to that person and then continue on. That way people in the future can maybe add on additional, weights to this person. All right, so that's kind of the most complicated logic, I think, in this whole piece of code, this whole code base here. The next thing that we'll look at is the actual vote function. And this is where we actually cast our vote, or the user casts their vote. The vote function takes in a proposal integer, and this is going to be the index of the array that we want to vote for. So if we passed in 2 items to the array and we want to vote for the first item, then this would be a 0. If we want to vote for the second item, this would be a 1, so on and so forth. We then get a reference to the voter, and we store it in a variable called sender by looking at the address of the message sender and kind of doing the lookup in the voter's mapping. We then make sure that the weight of the voter is not 0, because if it is 0, they are not allowed to vote. We make sure that the sender hasn't already voted, and then we go ahead and set that the voter has voted. So we set the voted value to true. We then set their vote to be the proposal that they voted for. And we then go ahead and increase the vote count for whoever they are voting for to be the weight that they have attached to them. Now, by default, when they first are given the ability to vote, this is going to be a weight of 1. If they've been delegated more votes, then this will kind of be incremented to however many votes that they've been delegated, right? So that is going to be kind of their weight, and we kind of tack that on to the vote count. And then we have a couple of functions for retrieving information about the current voting. The first thing that we have is a winning proposal function, and the other one is a winner name. And the winning proposal is going to go ahead and recalculate the winning proposal whenever this function is called. So basically, we go ahead and we set the winning count to 0, and we loop over all of the proposals, and we then continue, setting the winning vote count to be whatever the highest value is in this loop. So we check to see if the proposal count for the current item in the index is greater than the current winning vote count, and if it is, then we go ahead and reset the value of the winning vote count, and we reset the value of the winning vote proposal. And then finally, we have this function for getting the winner name, and that just returns the proposal name for the winning proposal. And there we're basically invoking the winning proposal function again. So what we can now do to test this out is we can go back to our terminal and go ahead and copy the value for one of the candidates here. So I'm going to go ahead and copy the value for Natter, and I'm going to go ahead here, and I'm going to say I want to go ahead and vote for this person. So I can do that from this address. Well, actually, I think I need to give the right to vote first on that. So yeah, let me go ahead and copy the address for this person. I'm going to give them the right to vote. I'm going to copy the address of this person, give them the right to vote, and then finally I'm going to get the address of this person, and we're going to give them the right to vote. So we've now given 3 people the right to vote. So I'm going to now start voting. So for the first account, I'm going to vote for me. Actually, I think I can just pass in the index. What am I talking about? So when we deployed this, we passed in 2 items. So I'm going to go ahead and say I'm going to vote for 0. And then for this account, I'm going to vote for 1. And for this account, I'm going to vote for 1. And there we go. And we might want to even test this out by voting for with an account that hasn't been given the ability to vote. So let's see what happens if we do that. We should see an error. So we do. So that all of the logic seems to be working. So let's say that we're kind of done voting. Let's go ahead and try to calculate who's the winner. So I can go ahead and say, winning proposal. And we see that the winning proposal is 1, which is right because we cast 2 votes for 1. And if I get the winner name, then we get this, bytes 32. And if I go to my terminal and I look for the value with 6579, I see that the winner is Ashley. But let's say we kind of want to read this value back to us using the bytes 32 value. Let's look at how to parse the bytes. So we're going to kind of maybe copy and paste some of this code here. And, we'll rename this to parse bytes. Okay, and we'll take in an argument. So all this stuff might be the same. Instead, we'll call this bytes. We'll call this name, because it's going to be kind of the opposite way around. And instead of format bytes, we're going to use the utils.parse bytes. So utils.parse bytes 32 string, and I think this should work, except I need to pass in the bytes here. So let's go ahead and try to do that. So what I basically want to do is kind of take this value here and turn it into a string. So the way that we're going to do that is we're going to say node parse bytes. And there we go. We see that we have the name of Ashley. So it kind of gives us an idea around who won that. Now, the last thing we might want to do would be to consider why we're using bytes 32 as opposed to a string anyway, because a string is a lot easier to read. And I kind of wanted to go ahead and go over that. So there's a really decent Stack Overflow, maybe a good Stack Overflow overview or Stack Exchange. And the end of the story here, like the basic, boiling it down, is because bytes 32 uses less gas than a string. So it's kind of more efficient than using a string. It's less readable, but it's more efficient. So you can kind of do your own logic to maybe parse the string, on the client or wherever you need to read it. There's the trade-off, though, of kind of like doing that extra work versus having a lower gas cost. But let's say we did want to use a string. So instead of doing the bytes 32, let's kind of change this out to a string. So all we would really need to do would be to kind of look for whenever we use bytes 32 and just change this to a string. So let's change this to a string. And then this needs to be a string. And then I think we might need to update one other area here. And this needs to be a string. Actually, let's try this one more time. Okay, we just need to say memory. All right, there we go. So we kind of just updated bytes 32 to string, and let's try to now deploy this with the string. So what I might say here would be natter Ashley. And we'll go ahead and deploy this. And we see that it's deployed successfully. And we might want to go ahead and start delegating some votes. Oops, I deployed it to a different, contract address, so that's fine. I can still work with that. I'll go ahead and give this person the right to vote. And I will go ahead and vote. This time I'm going to vote for natter. And now when I get the winning proposal, it should come back as 0. When I get the winner name, it should come back as natter. Because we're now using a string as opposed to the bytes 32 data type. So I think that's it. I think if you're this far along and you've stayed with me, you probably have a pretty general good understanding around how to write some Solidity code and how to write a smart contract. So that was quite a bit of information, but it's really interesting, I think, to kind of walk through all this stuff and look at how it works. Now, me as a full stack developer, I wanted to understand how to actually use this with the actual application on the front end. So if you're interested in that, check out my video, The Complete Guide to Full Stack Ethereum Development. It kind of shows you how to connect a front end to a smart contract that's been deployed, but it also shows you how to actually set up a development environment and deploy to an actual network and all of that stuff. So thank you for checking out this video. And if you're interested in looking and hearing more, subscribe and maybe even turn on notifications for future videos. And until next time, I will see you around. Thank you.